And welcome back. Let's have a look now at what the textbook refers to as the composite function rule, but what's often referred to as the chain rule. So we're now doing some more differentiation, but it's going to be a little bit trickier. Now this is the chain rule, and it won't mean a lot to you at the moment, but the chain rule is dy over dx equals dy over du times du over dx. And when you look at it, you could almost imagine an imaginary cancellation actually occurring with the du's, and you're left with dy over dx. And that's effectively what the chain rule is doing. So let's actually have a look at the chain rule in action. Here's our first example. Differentiate y equals 3x take 2 in brackets to the power of 5. The only way we know how to differentiate this question based on the skills that we've learnt so far is to actually write that bracket out 5 times and expand it out with your FOIL method or whatever technique you want to use. But that's going to become quite a messy, complicated little process to expand that bracket 5 times. So in order to avoid doing that, we're going to use what we call the composite function rule, or what I'll refer to often as the chain rule. Now, the way the chain rule works is we look at a certain section, and most times it's going to be what's inside the bracket. Now if you look inside the bracket, I've got 3x take 2. So we're going to let u equal 3x take 2. Now if u equals 3x take 2, we can differentiate u with respect to x, and we can generate du over dx equals 3, because the derivative of 3x is 3 and the derivative of minus 2 is nothing. So we can do that. Now if we actually go and focus back on the original question, if we're going to let 3x take 2 equal u, the original question could, instead of being written as y equals 3x take 2 in brackets to the power of 5, that 3x take 2 could now become u, because we said over here, let's let u equal 3x take 2. Now if I've got y equals u to the power of 5, I can differentiate that. And I'll differentiate that with respect to u. So differentiating this with respect to u, the power above the u is 5, you get 5u new power 4. The derivative is 5u to the power of 4. Now we're going to use our chain rule, or our composite function rule. Here's our formula. dy dx equals dy over du. Now what is dy over du? Well, we found that over here. It's 5u to the power of 4. Multiplied by du over dx. Well, what's du over dx? Well, we found that over here. It's 3. So effectively, we're just doing 5u to the power of 4 times 3. When we look at that, we can see the 5 times the 3 gives 15. So you get 15u to the power of 4. But if we go back to the original question, at no stage was there a u in the question. What's u actually equal to? 3x take 2. So now we've finished differentiating, we can return the u back to a 3x take 2 in brackets, and that is the derivative of 3x take 2 to the power of 5, nicely factorized, and we didn't have to expand the brackets out. It's a very, very powerful method. Let's try it again. Here's a second example. We've got a bracket to the power of 12. Inside the bracket's quite messy. If you had to expand that bracket and write it out 12 times and expand it out, that would become a very difficult and messy question. Let's try using our chain rule, or composite function rule. Now we're going to have to let u equal something. Well, we're going to let u equal the inside of the bracket. So let's start by saying let u equal 3x squared plus 4x take 1. Now we're going to differentiate u with respect to x. So du over dx equals, what's the derivative of 3x squared? That will become 2 times 3, 6x. What's the derivative of 4x? That would become 4. So du dx equals 6x plus 4. The minus 1, differentiating a number, just drops out. That's the du over dx part, but we know that if u was equal to 3x squared plus 4x take 1, that we could rewrite the question, and wherever we see 3x squared plus 4x take 1, we could put in its place the letter u. So we get y equals u to the power of 12. If I differentiate this y with respect to this u, 12 goes out the front, u, new power 11, dy du equals 12u to the power of 11. Now I'm ready to use my formula, the composite function rule or the chain rule. Do I know what dy over du is? Yes, I found that here. Do I know what du over dx is? Yes, I found that here. Need to be careful because there's more than one part here, so I'm going to be using brackets. If you don't use brackets, you'll make a mistake. So I get 12u to the power 11 multiplied by 6x plus 4 in brackets. Now if I look at this 6x plus 4, it's actually got a common factor. 2 goes into 6, 2 goes into 4. So what I could actually do is take that out. But before I do that, I'm actually going to just remind myself that what u equals, u is equal to 3x squared plus 4x take 1. So that bracket now has an 11 above it because u has 11 above it. Now I'm going to look at this bit and take out the common factor of 2. There are no common factors for this bracket. Taking out that common factor of 2 gives me 2 bracket 3x plus 2. That 12 times that 2 gives 24. So I end up with 24, 3x plus 2 in brackets, and 3x squared plus 4x take 1 in brackets to the power of 11. Quite a messy question. However, nowhere near as messy as multiplying the original question out completely and then differentiating it. So you can see the power of the chain rule. Let's try a third example. Third example says y equals the square root of 4 take x. Now, you cannot differentiate when we have a square root sign. We need to get rid of that square root sign, and we talked about that in the last exercise. Square root is equivalent in indices as saying something to the power of a half. So we can actually rewrite the square root of 4 take x as 4 take x in brackets to the power of a half. Now I can differentiate that using the chain rule or the composite function rule. Look inside the brackets. 4 take x is inside the brackets, so that's what I'm going to let u equal. So let's let u equal 4 take x. If I differentiate u with respect to x, looking over here at the x's, minus 1x, derivative of that will be minus 1. 4 out the front I didn't worry about because the derivative of a number is 0. So we end up with du over dx equals minus 1. But what do we know u equals? Well, u equals 4 take x, so let's have a look. That means if u equals 4 take x, then y equals u to the power of a half. So we get y equals u to the power of a half. If we're going to differentiate y with respect to u, the half goes out the front. U to the power of, what's a half? Take away 1 would be minus a half. So you get a half u to the power of minus a half. Let's use our chain rule or composite function rule. Now I know dy over du. I found that here. I know du over dx. I found that earlier on. So I can plug those values in and I end up with a half u to the minus a half times minus 1. Well, that minus 1 can times to the half, and that'll give me minus a half u to the power of negative a half. Let's return this to the form that it came. Now, if that's a u to the minus a half, I can move that down to the bottom of the fraction to join the 2, and it would become u to the power of plus a half. But what's u actually equal to? Well, we're told u is actually equal to 4 take x. But u is also to the power of a half, and I could think of that as the square root of u. And then I can put the 4 take x in its place, and I end up with minus 1 on 2 square root u, which is the square root of 4 take x. Quite a complicated little question, but once you've done a few square root questions, the process will be similar. You'll be able to get the answer out quite quickly. Now, that method is fantastic, but there is a shortcut which saves doing all of those questions with many steps of working, we can get the answer in 1 or 2 steps often. Now this is quite a complicated formula, so let's see if we can make sense of it. If we have y equals something in brackets, something with x's in it, to a power. So y is equal to some bracket with x's in it to a power of n. The derivative will be the power gets multiplied out the front. Then you multiply by the derivative of inside the brackets. Then you rewrite the bracket exactly as it was written in the original question, but decrease the power by 1. If you follow that rule, you'll be able to differentiate almost instantly. Well, let's try it and see if we can actually get it to work. So we've got the rule up here so we can look back at it. Y equals 6x take 1 to the power of 11. Now I could have used let u equal 6x take 1 and followed that process through, but I don't want to do that. Let's look at the question and say, okay, the derivative is going to equal to, I've got something in brackets to the power of 11. Something in brackets to the power of 11. So n is 11 in this case. So I'd start with 11. Times the derivative inside the bracket. What's the derivative of 6x take 1? Well, the derivative of 6x is 6. The derivative of minus 1 would be nothing, so it's just 6. And then we rewrite that bracket as is, except the power is decreased by 1. So we get 6x take 1 to the power of 10. Now that 11 times 6 out the front becomes 66, and we've differentiated the whole question using the chain rule quite quickly. A whole lot easier than expanding that bracket out 11 times. Let's try it again. Example 5. Again, we've got a bracket raised to a power. So let's differentiate that. The derivative is equal to, the power gets multiplied out the front. So we get 5 times, what's the derivative inside the bracket? Derivative of 3x plus 7, derivative of 3x is 3. Derivative of 7 is nothing, so we just get 3. Multiplied by the original question, the brackets, but the power is decreased by 1. 5 times 3 is 15, so the derivative in the end is going to be 15 multiplied by 3x plus 7 all to the power of 4. Powerful differentiation using the chain rule. Let's try question number 6. Now this is written in a slightly different language. This d over dx means differentiate the following with respect to the letter x, and this is our following part. So it's just like what we've been doing earlier, except we can't differentiate when x is on the bottom of the fraction. So I'm going to need to move that whole bracket with the power of 3 to the top of the fraction, and that will change the power from a 3 to a minus 3. So I'm still differentiating with respect to x, but I've moved that whole denominator up to the top, and the power changed from a plus 3 to a minus 3. Now I can differentiate. When you're differentiating, you look at the power and multiply that out the front. The power is minus 3, so let's write down the power, which is minus 3. Differentiate inside the brackets. The derivative of 3x take 2 is 3. Rewrite the bracket and decrease the power by 1. So you get 3x take 2 to the power of minus 4 when you decrease by 1. Minus 3 times 3 at the front becomes minus 9. But the question was written without any minus signs in the powers. So that bracket now with the minus 4 can move down to the bottom because that's really a minus 9 over 1. And it becomes minus 9 over 3x take 2 to the power of plus 4 once you move it to the bottom of the fraction. There's our answer. We've differentiated that. So quite a powerful technique to learn this shortcut method. It's far quicker than using the chain rule when you're using dy du and du dx. Time to do some questions. Have fun.